Okay, well, I'm not really amazing with magnetism as a whole, Maxwell, Gauss, Faraday, amperage law. We're gonna get into this here, and again, let's just begin by talking about some numbers that we're gonna talk about in here. I'm gonna bring in monopole and bipole. Talk about this in the terms of trig or spatial geometry to determine magnetism, not necessarily field. The calc will correlate to say if at a distance from a core of a planet you could quantify that it's a magnetic by the atmosphere passing through something in that area as a test, creating a aurora borealis or whatever by the IH effect, some bars, some brick, some north-south code coming down for what's in the field. If it's a bar magnet or it's one of these, it correlates to data compressed ones and zeros, true false. It's in the position of the hydrogen wave function. Not to be here, some a satellite. It can be satellite would be a good mod to help everybody tell time, mean Greenwich time. But we're still just looking at like, okay, so if an object there, a moon, something acting orbitably in a free space is going to continue to acting in motion to the rough approximation is in that area, and if it covers that mass having magnetism like that, or the effect of why the pressure limit of liquid oxygen makes it magnetic. Liquid oxygen is a superfluid and it's a little bit magnetic. There's a few other properties at the node there that busts off given square and not square. So that's again like a field, a polarized field. The yes at x, y, and z, it has limits. So this is a bunch of them kind of stacked up at the approximation to a square area that hedges that approximation to, again, the amounts here are nodidium, portionally models of nodidium, iron core, magnetism, electromagnetism, YF over X, to the three-phase motor, trig, instead of the XYZ that would then say T is amplitude, right, or intensity, which is a black body problem. It pegs to say, well, if the molar mass is to those amounts at that approximation, instead of figuring that out the inverse, because again, when you get into Maxwell, Faraday, amperage, and Maxwell and Faraday, or some equation like that. Those integrals, infinity big, infinity small, minus, a button toggle switch to that type of magnetism. So that's why the trig in a three-phase motor creates magnetism out of copper and a steel nail, right? It's if you have a nail that length and a wire of something like that, then the magnet's amplitude on trig is going to be this strong. Those are kind of proportions to the amounts we're going to put inside here, Bernoulli. What does a magnet look like? Here in a second.
A bar magnet looks like the following. Bar magnet. Let's see if we can spell correctly. It looks like this. It's a bar.
Bill Stoker,
and as Professor Dalakashvili told us,
and real world
a magnet has a north pole and a south pole. Okay, you're all familiar with this.
They're on gravity. All of them are guys, people. They stand roughly this tall. They hold roughly 75% water.
Okay, so I'm going to cut the thing in half, right there.
Bars and magnets. Okay.
And if I do that, that south pole is down there, the north pole is up there.
Kind of how you know it's a bipole.
Is that it? Is that all that happens?
This thing will get all bipolar when you do that, because
you in fact develop two
they're still connect to each other. I think
both of those have a
turned around though, then it'll get all bipolar and start to.
And now
one
if
of
you
these
do it
will
again, and
flip
I
around and do something.
Piece and that little
E,
piece,
I, or H,
F, has a north
H,
pole and a south
T,
pole.
let's say.
Okay, north
sure.
and south, north and
Same
south,
thing, different.
and
Got
so
it.
on.
And so then the binary quadrants of that
Okay,
start
and
to
you can
spectrum.
keep doing that all the way
This will start to
down
lose
until you
magnitude
get
and
to
intensity
essentially nothing. And at
and
no
change
point
its half-life.
do you
essentially, because this is a decay state by proportions and amounts,
just
to say,
a
well, if
North
there's an
Pole
amount
or
of
just a
uranium,
South Pole.
it's not just going
And
to
this is the
decay,
statement,
it's going to oxidize first. That's its
there
first
are
level, is
no magnetic
oxidation.
monopoles.
And so at the half-life of
Okay?
those things
You
times the
can't
weight,
have just a
or
North
the
Pole.
amount, the
You
space,
can't have just a
right,
South
that's going
Pole.
to give you
Anytime you have a North
current.
Pole, you
with
automatically
a straight
have a
line
South
current
Pole.
monopole
Okay?
to the magnetic
North and
field,
South
same change flip,
always
turn
come
into energy.
together.
That energy is fields that are emitted, whether they be electric
And this is
fields
very different
are
than
kind of
charge.
hard to. I mean, thermodynamics, you could tell a
When we
temperature
talked about
index with
charge, you
mercury,
can have
right?
a
It expands,
positive
it
charge
decays.
sitting all by itself.
There's a bit of a movement.
You can
It's
have an
more of
electron
a
sitting all by
gravitational
itself.
base wave
But
that
you can't have a North
it
Pole
wants
just
to
sitting
be in
all
one of
by
those
itself, or a
positions,
South
right?
Pole
But there's a
sitting
lot
all
of
by
Aleph
itself.
0, Aleph 1
Now, there is
between
a little
this,
bit of a caveat,
Aleph
which
N,
Professor Dalekashvili
which is a monopole
alluded
kind
to.
of trig problem.
There are theories
Change in
that
field.
magnetic monopoles should exist.
If one of these they're doing
that
something
there
with
should
spin,
be
then it
a North Pole all by itself, and there should be a South
fractalizes,
Pole all by
compresses
itself.
itself. It's
But
saying that the
currently,
gravity
there has been
increased and
no
it created a
experimental
field.
proof that those exist.
If gravity can
Okay, so
compress the
this
temperature,
is the
that
current
density-wise, as
understanding of the
the
universe,
heaviest of elements are
but
going to drop to the
10
base.
years from now, 50 years from
And
now,
of course,
this
we can
may no
tell
longer be true.
nuclear explosions
Remember,
to Reno
physics, like any
A1 to
science,
the density of
is
the
an
core.
evolving
About as
field.
close you're going to get there.
Okay? We are continually evolving our models of the universe, and this is the current understanding. But 10
And the
years
magnetism,
from now,
again,
50
is not
years from
just the
now, maybe in
planet
your
Earth. It
lifetime,
is not just a
maybe
black
they'll
hole.
say,
It's the dynamics
there
are the
magnetic
surface of the sun.
monopoles. We found them definitively, and here they are.
Well, here,
Okay.
Mercury, Venus, Earth, Mars.
All right. What do these magnets
9.8
do?
meters per second.
Well, I have a magnet